There are some questions that have been sent to us, and we want to look at it, but we'll take them one after the other. My WhatsApp number, I dropped my WhatsApp number last time, and I think we want to start now to make sure that everybody is following. And then the first question that was sent to us was under moments that I actually brought out. The question I actually brought it out, it says what? The question says that a uniform rod, meaning that physics calculation, says a uniform rod 1 meter long, weighing 100 Newton, is what? See, is supported. Is supported. Weighing 100 Newton is supported horizontally. Supported horizontally. On what? 2 knife edge. Two knife edges, A and B. Place what? At what? 10 centimeter. Place at what? 10 centimeter. From what? Its ends. Its ends. So what it will be, what will be the reaction? What will be the reactions at the support when 40 Newton weight is suspended? Suspended 10 centimeters from where? From the mid what? Point of the rod. Now look at the question. Please copy the question. Let's see. Now the question, I want to go back to the question. Now what we want to do now is this. Look at the board. I said a uniform rod 1 meter weighing 100 Newton. Now the rod itself is 1 meter. So we draw it 1 meter. Now if you miss the diagram, you have missed the question. 1 meter is written down 100 centimeter. 1 meter is equivalent to what? 100 what? cm. Because we check other things, they gave us a cm. And they say weighing 100 Newton. So that means the weight of the rod will be at 50 centimeter mark. It will be at 50 centimeter mark. Now, please don't forget that if it's at 50 centimeter mark, meaning that the word is a uniform rod, and that's why we have considered it. The question that they sent to us is uniform rod. So if it is uniform rod, just forget that the center of the word of the uniform rod, that is where the weight of 100 Newton will be acting. There's one key point you should know, that the weight of a particular rod or an object is always at the center of gravity. The center of gravity is the point where the gravitational pull of the earth tends to act. Now that is the first thing. So whether now to balance this particular rod we use pivot. So it's pivot we use to balance a particular rod horizontally. We use pivot to balance a particular rod horizontally. So the question says a uniform rod 1 meter long weighing what 100 is supported horizontally on two knife edges A and B. So place at 10 centimeter from each end. So one support is here, one support is here. You understand now? So the knife edge is A and B. So this place from here to this place is 10 centimeter. So from here to this is 10 cm. Then from here, from this end to this place is 10 cm. That's what they told us. According to the place at 10 centimeter from each end. They say, what will be the reaction at the support? So there is a reaction here. Reaction here. Let's call it R what? A, because this A. Then there is this B. So the reaction that will be acting here will be RB. Let's call it RB. Now we are not done. So they say reaction at the what? Support. When 40 Newton weights is suspended at what? 10 centimeter from the what? Middle or from the midpoint of the rod. So that means I can put it here, I can put it here, anywhere I want to put it. You know why? Because here is 10 centimeter, here is 10 centimeter. Anywhere I put it, you are correct. Because even the question did not specify from the what? Midpoint. The midpoint, I mean, this is middle. We want to measure it from the middle. But we don't know whether to take it to the right or to take it to the left. But anyhow you take it, you are correct. You still going to have the same answer. So you measure 10 centimeter from the midpoint to the right. I'm your load here. What is the load that will be placed there? Is 40 Newton, according to the question. This is the what? The weight. So that is just that. Now, the question says, you calculate the reaction. Now, the first thing you have to understand is that the sum of forces in the system will be equal to 0 because they said it's supported horizontally. That means equilibrium is achieved here. And since equilibrium is achieved, sum of forces will be equal to 0. So upward forces must be equal to what? The sum of what? Downward forces. So if you agree that now, that means our RA is upward positive plus RB, don't forget reaction always act upward, equal to what? The weight. Now this one now, let me remove this pivot because since they balance it on the two sides of the pivot, you don't need that pivot again. So this is the weight now. So we have what? Weight is 100 Newton than what? We have another one acting what? 40 Newton. So equation 1, RA plus what? RB equal to what? 140 Newton. So that is 140 Newton first. Let's call this one equation 1. Now, equation 2 is that what? Now listen and listen very well. Now, you have to what? The sum of moments must be also be equal to 0 for this system to what? To be in equilibrium. And the law for that one is say what? The sum of what? Of clockwise movement, sum of clockwise movement must be what? Clockwise movement must be equal to what? Sum of what? Of anti-clockwise movement. So now, since we now have this as our what? Our formula now, that means sigma A what? Anti-clockwise moment is what was sum of what? Clockwise moment. So what is our clockwise moment? Now let's take moment. Take moment about what? Let's take moment about what? Take moment about what? Let's say B. If you take moment about B, then the force RB will be equal to 0. The reaction RB will be equal to 0. So this one will go there. This one will come here. This one will come here.
So how many clockwise movement do you have? This is clockwise. This is anti-clockwise. And this is also what? Anti-clockwise. So we now have two anti-clockwise and what? One clockwise. So in that case, now what do? The product of the force and perpendicular distance to this place. If from here to here is 10, and from here to this place is 40, don't forget, from here to this place is 10, I mean from center to this, where we hang this load is 10, according to the structure. You check, they say, when 40 what Newton weight is suspended 10 centimeters from the middle of the rod, So here is 10. Here will be what? AC here is 10. Here will be what? 30. Please take on that. 30 cm. So that 10 plus 30 plus 10, everything will give us 50 to that end. So from here to that place, we have 50. Now, having known that now, what we want to do now is this. We are now going to what? Relate that now. Anti-clockwise. Well, since you are taking moment about this point, it will have the moment about B is equal to 0. So that means another 40. We are taking clockwise first. 40 Newton times what is the perpendicular distance from here to this place is what? 30. You need to convert to meter. So just what, leave it like that. Then another clockwise is what? No, this anti-clockwise rather. The 40 times what? 30. Another anti-clockwise you want to have is what? 100 here. What is the perpendicular distance of this 100 to this point where we are taking moment about? From here to here should be 40. Recall that here is 10 and everything to this place is 50. So if that is from here to here is 50, here is 10, and from here to here is 40. So now what? 100 Newton weight of the rod times 40 centimeter. So equal to what? The only anti-clockwise you now have is what? RA times, from here to here is 40. From here to here is 40. So 40 plus 40 give us everything from here to here, 80. So 80 centimeter will be from here, from this place to this place now. So that means RA times 80 centimeter. And even if you look at it from here to here is 100. If you remove 10 and you remove 10 here, the remaining one will be 80 now. So that is just that. Now, how do we make our RA instead of the formula? RA will now be divided both sides by what? By 80 cm. Divide by what? 80 cm. So this one will cancel this one. Now, what I want to do now, this one will give us what? 1,200 what? cm, Newton cm, plus 400 times 40 give us what? 4,000 Newton cm. Okay. So this one now give us what? Divide by what? By 80 cm. So this one now will now give us what? 1,200 plus 4,000 should give us what? RA equal to 5,200 Newton cm. Divide by what? Newton cm. You go 1, 2. So divide by 80 cm. So 80 will cm will cancel cm. 0 will cancel what? 0. So 528, 4 here what? 2. Then 4 here will give us 4 in 5 is 1. In 12 is what? 3. Then 0. Think so? So that's what we want to have. Now, then divide both sides by what? 2 again. I want to have was 65 Newton. That's what I want to have. You can press your calculator to confirm it. Very important. Press your calculator to confirm it. So I want to have RA to be equal to what? 65 Newton. Because if you have 5,200 times divide by what? Divide by 8, you have 65. I'm correct. So that is just that. So you write now. We'll give you 1 minute to write while we check question to see any question online that have been sent to us live. So please ensure you are with us live so that you can make your comment and contribute to whatever we are doing here live in this class. So please ensure that you join us live. Ensure you join us live. Write the question out. Don't forget, if you miss the diagram, you have missed the question. So if you don't get the question, that means you have failed. You are not going to comprehend what we are doing. So in that case, for you to comprehend, for you to understand, then it means that you have to draw the diagram well. If your diagram is wrong, the whole question is wrong. The whole question is wrong if your diagram is wrong. And don't forget, if it's a uniform body, the weight or the mass of the body always act at the middle of the body. So please take note of that. Very important. So if you have any question, you can ask us after taking the one that has been sent to us. So now we go to question 2. We'll take question 2. Then thereafter we move to to any of your questions that you have for us. Welcome to this live class. I don't know if you are ready for this class or you. Now, let's move to the next question. This next question has to do with what? With power. But in this case now, the question is more technical in the sense that it has to do with application. It has to do with application. So now let's see how we can tackle the question. Let's see how we can tackle this question. The question says what? A pump is used to spray what? Water from a pool. Determine if what? Determine the maximum what? Power of the pump. Power of the pump. If 40 liters of water is pumped per minute. Is pumped per minute. And the spray reaches what? And the spray reaches the maximum height. Spray reaches the maximum height of 60 meters. And now see what? Assume, according to the condition they give us, that 1 liter of water, assume that 1 liter of water has a mass of, assuming that 1 liter of water has a mass of what? Of 1 kilogram. 1 kilogram. And G is equal to what? 10 meters per second. Now, this is what we are looking for. We are looking for what they are giving us G, they are giving us everything we need for this question. Now, how do we go about it? How do we go about it? This is a technical question. Very what? Technical. So we have to be very, very patient in question and take it one after the other. One after the other. Yeah, that is how we have one more question. Then we listen to live class, live questions, apart from the one that have been sent to us on WhatsApp or have been sent to me via what our message. So please ensure you send what question to us so that we can view your question and know what you have for us. Now, in this question, as they said, a pump. The pump is what is used to what? To spray water from a pool. A pump is used to spray water from a pool. Determine the maximum power of the pump if 40 liters of water is pumped per minute. That means for every 1 minute, that means the time there first, the time is given to us as what? The time is given to us as 1 minute per minute. So time is what? 1 minute of that they used to pump, which is 60 seconds. They're speaking of that per minute. And they give how many liters of water was pumped? 40 liters of water was pumped. So in that case, and they told us 1 kg is equal to what? 1 liter. Now let us, if 1 kg equals to 1 liter, what is 40 liters going to give to us? So we cross multiply. What X kilogram? So if you cross multiply, what do we have? We are going to have it as what? That is, we are going to have it as 1 kg times 40 liter is equal to X kg times 1 liter. So what do we have in our class? What we are going to have is what? Divide both side by what? 1 liter. Divide both side by 1 liter. 1 liter. And what I want to have, this one cancel this one. So I want to have it as what? 40 kg. So the mass is now what? 40 kg. Mass of the water in kilogram is 40 kg. Now, another thing again we have to look at in the question, they gave us what? If you can know the mass, we can convert to what? To force. Force or weight, which is called to what? Mg. And what is G there? We know that G is 10 meters per second. So that means 40 times 10 will give us 400 Newton. That one is settled. Now, again, they gave us height from the question. They said, we pump per minute and the spray reaches a maximum height of what? Of what is the height of the spray? 60 meter. 60 meter. That's a calculate what? What is what? We are looking for the power of the pump, the maximum, not just power of the pump, but maximum power of the pump. So power is equal to what? Mgh over what? Time. Or because in that case now, for it to be pumped to a maximum height, the energy or the energy possessed at a particular body at the maximum height is what we call the potential energy. Energy possessed by a body at a maximum height is what we call potential energy. And the power what at that point is what? Mgh times over T. Don't forget the potential energy is the energy possessed by a body when it's what? It is virtually in position. So in that is to say that our power what? Maximum power, which is equal to what? Is equal to maximum potential energy divided by time. That's what it means. Maximum potential energy divided by time. So we are going to input our parameter there. The mass is what? Is a 40 times. Somebody else can say, what about if I say FH over what? Over time. You see correct because mg got to what? H is got to force. So in that case now, times 10 times what? times 60, 40 times 10 times 60 divided by what? What is the height there? The height is also what? 60. I mean, the time is also 60. Convert to seconds. So what do we now have as our what? Maximum power? I want to have 400 what? Watt as the maximum power. So the answer to that question, the person that sent us that question, the maximum power we are going to have is what? 400 watts. So we'll give us 1 minute to also write if you are writing, because we know that we cannot just be solving this calculation. Sometimes you need to have time to digest it and also what? Write down. Thank you. Now let's go to the what? The next question. Now this one is under projectile that was sent to us. You know, it's similar to what we analyzed in our last video, but this one is a little bit different and technical that somebody sent to us. Now, this one now, he wanted to know how we are going to go about the question. The person wanted to know how we are going to go about the question. So that's why he is trying to see if we can solve this question. Now actually, this question has to do with projectile, but not the normal regular one that you give to us, and it's not too common in JAM. You understand? We always tell us to work with your scheme of work, but nevertheless, the only time they ask the question is just once. They've said this question once, and that was when they were asking for maximum height. No, not that was not maximum height. They were asking for time of flight. But I want to use this question that this person has given us to look at, see it in different way, so that at the end of the day, everybody can actually benefit. You will benefit, I'll benefit. Now let us go to the next question. The next question. Let's go to the next question. Next question, please. Next question. Let's move to the next question. Let's move to the next question. The question says that what? A stone is thrown what? Vertically what? Upward. Please, after we solve question, we'll give you time to write from what people have sent to us. I told you can also send question to my WhatsApp. You understand? This is my WhatsApp to see what you can do about it. So if you cannot type question, you can type it on WhatsApp and send to us. You understand me? So that is just that. Now, let us look at the next question. He said what? That a stone is what? Thrown vertically what? Upward. Now, if you throw a stone vertically upward, now from the top, of a tower, 50 meter what? High. 50 meter high, with an initial velocity of 20 meters per second. Calculate. That's one. That question gave us as 3 questions. Please let us try as much as possible to make it what not that one person be asking more than one question. Not that we cannot answer you, but so that other people can have the platform to ask questions. The maximum height, the stone reaches. That is number 1. 2, he said what? The time it what takes to reach what? The maximum height. 3, he's saying what? The total time the total time the stone spent in air. The last one that person asked was second to the last. It was about 4 questions. That's why we say people should make it very, that's it. Don't exhaust the whole time for us. The last one they say what? The velocity, second to the last, velocity of what? Of the velocity of the stone on the ground. That means what he wrote now is that he's saying that the velocity of impact on the ground. And the last one is total distance it covered. The total distance it covered. This one is not height. It's a total distance. Total what? Distance it covered. So you have what? This particular question to exhaust and to solve. Now, since we are giving this question is actually projectile. And one of the things we discussed yesterday was part of it, or in our last class was part of it. So before, that was the last live video on calculation in physics. Now, this one now they said the stone is projected upward. They gave us G. The G that was given to us was what? They said take G. Take G to be equal to what? 10 meters per second square. So that is what they give us as G, and I don't think they give us another. We don't even need another thing. Now, they say a stone is what? Projected vertically upward. That means that we have a stone here, a top of a building here, projected at an angle upward to the ground. Look at it here. That's what happened. A stone is projected, is thrown upward from the top of a what? Of a tower. This tower. This is tower here. The tower. This is tower. And the tower is about how many meter high? It is what? 50 meter high. 50 meter high. Now, since it's 50 meter high, it was projected with a velocity of what? 20 meters per second. That is velocity of projection. U given to us is what? Is that. Now, they say calculate the maximum height reached. The maximum height the stone reached. That is the first question. The maximum height the stone reached. Normally, that means it is measured from the what? The ground. But the maximum height the stone reached must be measured from where? From the ground level. So the maximum height, first of all, I will calculate the height from here to this place. I will now add it to the 50. the maximum height to reach must be what? This height from here to this place. That is, let me see, from A, let me label it. Let's say this is A to B, and from B to what? To C. So the maximum height eh, reached, maximum height reached equals to what? The height AB plus what? Height AC. So that is the height I want to find. But don't forget that, BC. Don't forget that BC is already solved too. They're giving you BC, which is the height of the tower. So we are looking for AB. Now, at A, at point A, at what? Point A, velocity is equal to 0. Now, velocity is equal to what? 0 what? Meter per second. Why is it 0 meter per second? Because at maximum height, the final velocity is equal to 0. Do not forget that. At maximum height, the final velocity is equal to what? 0. Then another thing again you must also comprehend and understand is that now the velocity of projection, initial velocity is what? 20 meter per second. They give us 20 meter per second. And also we know our G as what? 10 meter per second was square. Now the height from AB, that means HAB, is unknown. Don't forget H what? BC is 50 meter. That one is given. HBC is 50 meter. If I can get the height from B to A, I can take everything like this as a total height reach, the maximum height reach, which is measured. All heights are measured from the ground level, from the sea level or the ground level. All heights are measured from that point. So in that case, what we want to do is to solve for HAB. And how do we solve for HAB? We use what? V square equal to U square minus 2G HAB. Don't forget that what? We have what? V equal to U plus or minus GT. We have V square equal to what? U square plus or minus 2G H. Now this H is most of the times what? H1 minus H0. If you are, I'm going to explain that. Let me just read it like this first. Then we are going to have what? S equal to what? UT plus or minus half what? GT square. So now I will explain this S. Let me just put S here first. I will explain the S for you now. So in this case, the S is our H what? HB. Now, what do we do? Now we are going to have what? 0 square. I think those of you who have watched my live video last class, you should understand what S means. I've explained it before, especially when the body is going on. 0 square equal to what? 20 square. Why do we use minus sign? When the body is projected against gravity upward, use minus sign. So that will now give us what? 2 times 10 times HB. Now, what do we do now to get our HP? We what? We take collect like this. So I would have what? 20 what? We get what? 20 HB. That means you what? You take this one times this, this 20, then bring it to this other side. This one is already 0. So if you come to this other side, 0 plus 20 HB is what? 20 HB equal to what? 400 what? 20 square is 400. So HB, therefore HAB equal to 400 divided by what? 20 what? What do we have, class? We are going to have HB equals to what? 20 meter. Now, one thing you must understand, when you prepare for an exam, you find it easy. But when you don't prepare, that is when somebody will enter the exam or start crying. And that's why we try to see how we can help you to what? To achieve your aim. Because by this time, next tomorrow, the day after tomorrow, some people will have written. their exam this week in Nigeria. It's a Nigeria exam we call JAM, for those of you that are watching us from abroad or from UK, from America or from Canada. And that exam is a Nigerian exam that in order to enter a tertiary institution, it's an exam you write in order to gain admission into tertiary institution. And that's why we have organized this class, especially to also bless, apart from Nigeria, also to bless other people. And we have given a platform where students can also send in their question so that we can actually look at it. We can learn from your question. Now, look at it, what we notice here now. We have solved for the HB, which is from here to this place. Now, drawing the diagram, you observe now, clearly, you see that AB is already what? 20 meter. Now, from the ground, from the tower to the ground, that one is already what? 50 meter. So the total, maximum height reached? Height what? The maximum height reached? The maximum height reached is equals to what? Is equals to 20 meter plus what? 50 meter. And that will be equal to what? 70 meter. So 20 meter plus what? 50 meter equal to what? 70 meter. Plus 50 meter equal to 70 meter. So we have solved that one now. This one is solved already. So the next thing to solve is time to reach maximum height. So the time to travel from here to this place is what we are looking for, because this was where the stone was projected before it get to this point. So time to reach maximum height, that means it takes 20 minutes, 20 meters to get to that height. And if you want to solve such, now the velocity of projection on that place was 20 meters per second. Don't forget. So what I'm going to do now is what? To know the time from here to here, what I will just use, I can use V equal to what? U minus GT. I think that would be better. V equal to U minus GT, so that we don't stress ourselves. There are several other formulas you can use. This already have here to 20. But if you use this one now, you are going to have what? Our V is, what is our V? Our V is 0 at the what? At this point, this maximum height. Then it's projected with U equal to what? What is our U of projection? It projected 20. Is 20. That it projected 20. U is 20. 20 meters is here already. 20 meters per second. So 20 minus. Why do we use minus? Against gravity is going upward. So upward projection is minus. Downward projection is what? Plus. Upward projection is minus. Downward projection is plus. So this one will be what? 10 times T. So how do we get our T now? C becomes what? That means 10T becomes, that means this is 10T. Bring it here, it becomes 10T plus 0 is 10T. Then we have 20. That will start by what? By 10. Then we have T to be equal to what? 2 seconds to go up. That means time to reach maximum height is what? Is 2 seconds. It's maximum height. Then time to what? To reach what? The maximum height. Height is what? 2 seconds. Now the next one is of what? Number 2 now. We have solved number 1. Then number 3 says what? That this total time the stone spent in air. Now the total time is spent in air. There are 2 ways you can solve it. There are 2 good ways you can solve it. Either you solve directly to this point. Now taking what? This particular point as it. Don't forget, this is where the body was thrown and this is where it landed. Now, this method I want to show you is very fast and easy. Now, since it's where the stone was thrown from and this is where it landed. Now, where it was thrown from, what was the height from the ground? Because I told you the ground remained the reference point for all heights or projection. So that means from here to this place is 50. That means initial height. That means initial height is equal to what? 50 meters. That means where it was standing before it made the projection. after he had made the projection, the body spent, he went to the air, returned back slowly, and the stone landed on the ground, what at the ground level. So that means as the body is now, the final position, this initial position of the body from the ground is 50. The final position of the body, which is what? H1 or H final, as you can call it H initial, is equal to what? The final what? Height is equal to what? 0 meter, because it landed on the ground. So that is 0 meter. Now, how do we calculate the time is spent in air? We just use this formula, S equal to UT minus the time. Let's use capital letter T to differentiate it from this one. The time is spent in air is actually called total time of flight. Now, the time it takes for to reach the ground, so the total time is what the stone spent in air is what we call the time of flight. So that person that gave us this question, it can also be twisted that way. The question can be twisted that way, that calculate the total time of flight. So in that case, I want to have it as what? Half what? GT squared. We have gotten that one now. That is the formula from this place that we use. And we know why we use minus sign. What is your displacement? Your displacement is actually equal to what? H final minus H initial. That is your displacement. That a body is being displaced up before it is turned down. But a body can fall freely. Like a ripe mango can fall from a tree downward under the influence of gravitational acceleration. But a body cannot just rise up without any displacement. There must be a displacement before the body will move against gravity. We have it in sport like javelin. Javelin is a good example of what? Of a body projected against. This one is what? You have initial and you have the final position. And so that means H final is 0, then H initial is what? 50. So that means our displacement is what? Is minus 50 here. So it gives us a negative displacement. That means when the body was standing to make the projection, he is having a negative displacement with the ground. So that means that what? It is possible for displacement to be what? Minus. Don't forget that displacement is a vector, not a scalar. So it can be either minus or plus. Now let us put our parameter there. We have our U to be equal to 20 meters per second. We have our time unknown is X now. So our time is what? Unknown. So in that case now we are looking for time. Are we giving G? Yes, G is what? 10 meters per second what? Square. What else again? Our time is what we are looking for now. So I want to clean this side so that we can see what we are doing, or I can clean this parameter because I don't need it again. Let me clean this side. Please, if you are writing, you write fast so that we can get everything. Write fast so that you can get everything. Please ensure you write fast. So that is just that. Now, let me clean this side. Now, what we are now saying now is that using what? That formula, S equal to what? UT, let's differentiate it from time to the manual, half what? GT squared. Where T is what? The total what? Time where spent in what? In air by the stone. So that is to say, this one will be minus 50 equal to what? 20T minus half what? Times 10 times T squared. So what do we have now? What we are going to have now is what? This one, cancel this one. I'm going to have 5 below. Then this one, don't forget this one is the first person on this one in JAM before. So that person that gave us that question, you did well. It was 20T minus what? 5T squared equal to minus 50. Then bring this one, you would have 5T squared minus 20T minus 50 what? Equal to 0. So in this case now, we are going to have it as, let's say we divide both sides by what? By 5 or 2. Let's divide by 5 or 2 to reduce it. If you divide 5 all through, I would have what? T squared minus 4t minus what? 10 equal to what? 0. So that's what I want to have as our what? Now, if you have gotten that now, what we're going to do now is to use our what? Our quadratic formula method. Now, minus b plus or minus square root of what? B squared minus 4ac over 2a to get our time of flight, or the time spent in there. Don't forget your a is equal to 1, b equal to minus 4, and c equal to minus 10. So if you have that now, we're going to have it as what? What do we have? We have minus what? Minus 4 b plus or minus square root of what is square b is what? Minus 4 all was square minus 4 what? What is our a? A is equal to what? That time spent in a equal to 4 times a. What is our a? 1 minus 10 all divided by what? 2 times 1. So what is time of flight now? That will give us what? Minus is plus, is 4. So 4. Don't forget, the last question we have to solve is velocity of the stone on the ground. Velocity of the stone on the ground. So we will remember. So this one will not be what? 4 plus or minus. What I would have now? 16 plus 40. That means this one minus this one times this one is plus. 4 times 10 is 40. Divide by what? 2. So this one will give us what? 4 plus or minus what? Square root of what? 56 divided by 2. Now, I told you how to find square root of 56. You don't need to bother yourself. Square root of 56 is very easy. Now, if you want to find square root of 56, what perfect number is close to what? 56 is 49. So since 49 is close to 56, perfect number, and is smaller than that, we are going to have it as what? 49. 49 is the perfect number close to 56. So we have 7 plus. Now, if you have that now, 7 plus, now 56 minus what? 49 will give us what? That should be 7 also. Divide. That means 56 minus 49 should be what? 7. Then divide. Then this 7 we have got in here, we write 7 plus. That means we have already, this 7 is from 49 plus. How do we get this in this one? Is what? When you subtract, the remainder is 7. Then this 7 multiplied by 2. This 7, anything you get here from the perfect number, you multiply by 2. What I would have 14. So 7 divided by 14 is what? 0.5. So 0.5. So 7 plus what? 0.5 is what? 7.5. So that is what? The square root of 56 is equal to what? 7.5. So if you press your calculator, let me check. Let us do a check of that now. You will discover that I'm actually correct for that particular one. You can check it even while you are sitting there. You can bring your calculator out to check. As I'm checking also, you also do your check. So square root of 56 is approximately 7.5. This is 7.48. So why I'm doing that, because in our exam, in the exam you are writing, you should hear me. There is no square root in your calculator. So you find it difficult and tough to be able to solve. When you get to this point, you now be what? Stranded. And I don't want you to be stranded. That's why we actually help you with the square root of that one. So this one will not be what? Time of flight will not be 4 plus or minus 7.5 square root of that one. Divide by what? 2. So our final answer now be what? 4 minus 7.5 divided by 2, or 4. Now, don't worry, 4 minus 7.5 is what? Is what? Minus 3.5 divided by 2 is about what? What do you have there? Oh, so I have to clean this side. Okay, let me clean this side. We have written this. So Okay, 4 minus what? 7 what? Minus, we are going to have t equal to 4 minus 7.5 divided by 2, or 4 plus what? 7.5 divided by 2. So those are the two possible answer we can have. So that will give us what? Minus 3.5 divided by 2. What I would have, man? Minus 1 point, that is 75. 1.75. Then seconds. So this will give us what? 11.5 divided by 2. 11.5, which is written as what? 6. Okay, let me see. 5 point what? 5 what? 75 also. 5.75. So that's what you are going to get if you do that perfectly well. You can divide seconds. Now, but you know that we are having 2 times here. Then time can never be what? Negative. Time cannot be what? Negative. So since time cannot be negative, therefore you what? Minus 1.75 is totally incorrect, because time cannot be what? Negative. And time is a scalar quantity. It's not a vector. So most scalar quantity cannot what? In fact, all scalar quantity is not possible for a scalar quantity to carry minus sign. So time of light is equal to 5.75 seconds, which is time the stone spent in air. Now, the last one is what? The velocity of touching the ground. That is velocity of impact. So if you want to solve for velocity of impact on the ground, what we are going to do is to what? Use this formula. V square equal to U square minus what? 2G what? X. That is the formula we are going to use. Velocity of impact. That is from here, projected from here and hit the ground here. So we are making reference from starting of what? Point of projection to where it hits the ground. So as it starts from here, it starts with 20 and it hits the ground with the velocity V. So this V now is velocity of impact on the ground. The velocity of impact, we are looking for impact on the ground. So it's projected from here, from this particular point B, then it hits the ground at point D. So the velocity at D is what we are looking for. And let me use D. So we are looking for velocity at D on the ground. So that means, please don't forget that. Now, if you are doing that, now as the body is going up, you understand that it's going up. So we use minus sign. So somebody has said, Miss Haliday, the body is going up initially, then return back suddenly. It just return back. Then why not use plus since it's coming down? No, it is the instant. What happened to the motion of the projection or motion of the stone from here is what we consider. So it was first projected upward before gravity pulled it down. So you use minus sign. So velocity of what at D square is equal to what? What is our S? Our displacement is minus 50. We are going to use my displacement. That means the initial and final what? Height. That means final height minus initial height give us 50. So minus 50. So I would have what? 20 square minus 2 times 10 minus 50. So this is what I want to use as to get our answer. So what I want to do that we are putting our answer, then we are going to velocity of what? At D. So this will give us what? V D square equal to what? 400 plus what? Minus times minus is for plus. Then 2 times 10 is 20 times 50 is 1,000. 2 times 10 is 20. 20 times 50 is 1,000. So that is what I want to have now is 1,400. Because if you add 400 to this, we have 1,400 VG square. Now, what we're going to do in that class is to what? Find the square root of what? Square root of 1,400. Anything you get is your answer. Now, when you have this one now, what you are going to do now to find square root of this one, the 2 0 will give you 1. You take square root of 2 0, it will give you 1. Then square root of 14. Square root of 14 is what we want to take now. What perfect number is close to 14? 9. The square root of 9 is perfect number that is close to 14. And that will give us 3 plus, what do you call it? 14 minus what? 9 is what? 5. 14 minus, is it 5 or 6? It's 6, my dear. 6. 14 minus 5, 9 is 6. It's 6. Is it 6 or 5? It's 5, I'm correct. 14 minus 9 is 5. Sorry. Divide, then these 3 that we have gotten from perfect number of these, we now multiply by 2. Just like what we did here. We got 7 or 49, we now multiply by 2 to get what? To get 14, which is under this one. The remainder, how do we get 7? 6 minus 49, which is perfect number. We got 7. Then to get the denominator, we multiply anything that we have here by 2, that's 14. So this one now, what we have here, you multiply by 2, that's 6. So what I want to have now is what? 5 divided by 6 is about what? 0.8, then 2, I would have what? 8, then 2, I would have 3, then 2, again, 0, 3, and 0.833. So which means the final answer will not be 3.833 multiplied by 10, because this 0, 0, it come out at 10. Square root of 100 is 10. So this 0 I wrote here is like 10. Multiply this one by 10, I want to have about 38.333 as the answer meter per second. So in that case now, check your calculator very well. Check. That means square root of 140, square root of 1,400. Is it 38 or 37.1? Let me confirm it again. Let me confirm it. Square root of what? This one is 3 plus 5 over 6. So this is 5. Then if it's 5, 3, then 6 multiplied by 2. 0.50 is what? 8. Let me check. That is approximately 3.8 then. Let me check. Square root of what? 3.7. 14 minus 9 is 5. Yes, because this one now is what? Let me check something. If you check very well, check very well. This is 20. That means 20. Let me check it. Is what you can write it as 14 times square root of 100. That's what it. Square root of 100. Let me check again. The square root of 100 is 10 times the square root of 14. The square root of 9 is 3. Then if you add 5 to it, you are going to have 14. So that means that 3 plus what? 5 over 3 times 2 is 6. So 5 over 6 should be 0.8. Let me confirm it because I've been working since. Let's see what happened. 5 divided by 6. 0.833. Yes, correct. Then let's check what I check again. Let's check it. Okay, I've seen where the problem is now. I've seen where the problem is. The smaller the what, the value of this one, the danger this method will what. That means if you use it for what? Square root of what? 3 now or 5. The smaller the value, because it's an approximate method of solving square root. So what we do is that in the exam, once you find this one, once you find square root of 100, which is 10, the square root of 14 should be 3 point something, which is 3 point. So when you see 30 something, well, you should be able to. So this one will be 37.4. I think that one is what happened there was because the value of 14 is small. So the smaller it is, especially from 14, or let me say even 15 downward, down to 2, you find it difficult because of the smaller value. But if you take it on 20, 21, 22, 23, it will always work. It will always. work like that. It will always give you your answer. That is how it works. So please take note of that. Just try it for 20. Try the method for 25. It will work. It will work. So in case you have any question, let us know and you send it to us. But in the absence of question, I'm working alone tonight, alone. So we need your question to be able to what? Sustain this class. We need your question to be able to sustain the class. So you send your question across while we work with it. Now, question have been sent to us now. It's just now. Let's see. This one says what? Send question to us now. He said, what is the energy of photon of mass? This. Just send question to us, my phone now, my WhatsApp. Now, let us look at it. Don't forget, this class is calculation class. Calculation in physics. So when you send your question like that, we will try to resolve it. And once the question is not like somebody sent the question yesterday, and it's not like the question cannot be an ID piece. But in class, in a YouTube class like this, where people are watching,